Hello, I'm Sebastian from 29295C.
Hi, I'm Shohan from 29295B.
And I'm Eric from 29295A.
And we're going to do a bit of our robot explanation for our provincials robots. I'll start with mine and just go over the different kind of features. In over-under, obviously you have to collect these tri-balls. Our intake is a 1-motor intake, 11-watt motor. And we've got a sprocket on here with slip mat. And I've used these latex rubber bands. Go forwards, backwards, intake the tri-ball, and we have this, we've got a crossbar at the bottom the tri-ball just kind of rests on, and that means that I can drive around and I won't touch the ground. In order to stay in size, because we have to start in that 18-inch cube, I've got an intake drop-down mechanism. So we get this rope, we hook it on here, and this means that the intake will be held up until it spins. So at the start of every match, we just spin the intake slightly, and then it'll drop down like that. Next, we'll go over the drivetrain. So our drivetrain is a 6-motor drivetrain, so 66 watts. It's on 3.25-inch wheels, and we got 6 of them, or 4 of them, with a middle flex wheel, and that just helped us to get over the barrier, and it didn't hinder our driving at all because it doesn't actually touch the ground. So that's on a 36-tooth to 60-tooth ratio, which gives us 360 RPM, which we found was really good for this game. There's a lot of like robot and robot contact, so we're able to push robots pretty easily. Also on the drivetrain, we've got these sleds. So we've got sleds for getting over the barrier on the front and back, and those worked really well. We found that we had to change them a bit due to moving weight around on the robot. They kind of worked, then didn't work, and we had to change that a bit, but being able to get over the barrier both directions was just really helpful. I'll go over the kicker. So this was how we shot tri-balls. We didn't really use it much in games because the strategy ended up being to just intake the balls and bowl them down the alley, but we used it for skills. And so our kicker is a 1-motor kicker, goes right there. We've got a 36-tooth to an 84-tooth, and it's I think it's an 11-tooth slip. So we can just plop a tri-ball right on here at the perfect angle, and it flings it pretty far. And that was really good for skills. It was nice and fast. We found we actually had to weight the kicker head a bit. We just put a whole bunch of shaft collars on there, just because they're pretty heavy, because I wasn't able to hit the ball as far as we liked. So that really helped with the weighting on there. Right attached to the kicker is our hang mechanism, and it's actually both hang mechanisms. So we have a barrier park, and we also have a elevation bar hang. So this would go over the bar, imagine my arm's the bar there, and then it would pull the robot up using the power of 4 double-acting pistons and a bunch of bands, you can see right here. And then at the same time, as that goes up, this rope right here, it pulls our park arm down. So do that again. So it folds back in, and then when we put it up, the park arm folds down just like that. And so that just meant that we can double park if our teammate has a hang and we have a park, or if they have a higher tier hang than us, because it's got B tier hang, and a lot of robots could get C tier hang, so that meant that we had options. 2 final things I'll go over. Wings on our robot. So wings were a big part of skills, and were used in autons and matches quite a lot. Our wings are, I think they're 20 holes long or 19 holes long. And we've got these sheets of polycarb on here, and they're wedged so that we can get tri-balls over the barrier. That worked really well for field controls, being able to push them over really quick to our teammate, and also in skills, being able to push them over. And you can see our wings, they pop up like this, and that just meant that we can get over the barrier. So on the corners, we're able to go like that, which gets the wings over the barrier, but then when pushed from this way, they can't get over, which means that they can push the tri-balls over the bar. And then on the wings, we also have this locking mechanism. So we've actually had this locking mechanism since like the start of the season. I believe it's called a double pendulum. Yeah, it means that when force goes against the wing, rather than going down the piston, which can kind of contract pretty easily, we have it go down this bar right here, and that just means that they lock in place, so the wings can't go anywhere, but then when you want them to retract, they just pull back like that. And that worked really well. That's just done with screw joints and standoffs and shaft collars. So that was really great. Another feature we have is we have this one-way intake system. This was more helpful when we didn't have the climb here because we could actually load tri-balls through our intake. But what it was, oh thank you, is when we intake, it just stopped the tri-ball from going too far. So it would hit this bar, and it meant really couldn't go anywhere. But if you put it in from the other way, it will actually move out of the way for the ball, you can see there. And that meant that you can load through the intake and bowl down the alley really well, which was great. The plate on the back, so that's wedged so we can push tri-balls over the barrier, which is really helpful. The final thing I'll mention is just these wall riders here. So that just, when we hit the edges of the wall, instead of getting caught on some edge, we can just roll across. And that helped quite a lot, just to make driving a bit smoother. So yeah, overall, really happy with this build. I shout out to Matthew for giving me this piston at competition in elims because our hang wasn't working and we needed one more piston to make it work. Yeah, so it's been really good with this robot, and I'll go over to Merrick now so he can explain his robot.
Alright, back to 29295A. We got a bit of a yapper. So what we have here is just a basic over-under bot. We have the regular puncher, wings, intake. I guess I'll take it from the bottom up. So for our drivetrain, we have a 343 RPM drivetrain that's 48 to 84 on 4-inch. It's really easy to get over the middle barrier with this. Our sleds are kind of scuffed. We've had them from early season, haven't broken at all. But it gets over very nicely, so we didn't have to change it at all. We have this center flex wheel just to additionally get over better and a lot smoother without that little jump which you normally get from curved sleds. Moving up, we have these nice wall riders. We use a 48 tooth on those, very good friction, and it's nicely braced across. For front of the bot, we just have a normal polycarb wedge. It's held up by 2 screws here. For intake, we have intake sleds made of polycarbonate. With, similar to them, we have latex tubing on the intake, just a normal sprocket intake with mesh. We mounted this, the tank, on top of the intake, just for better weight distribution when we go up for our hang. We don't have a traditional hang, but we just have a regular park, which comes out with this. And that gets up about 95% of the time, only misses when the driver misses. In terms of wings, we just have regular vertical wings. Those are really great for pushing. They're triangle braced at the back here, so we never have any issues with those bending. Additionally, we have this nice cut-in into our wings so that when we come onto the bar, mostly to de-score the corners, it can nicely ride on top of that and wedge balls out. Moving on to the puncher, we have a 36 to 84, which is 43 RPM. And that gets going pretty fast. We have that on a double slip, I think it's 10 teeth. And normally that can do about 140 shots per minute, but we tone it down a few so it's a lot slower for matching. And it works pretty well for shooting. This. That was there for when we were match loading in skills, because we only really use puncher and skills. Whenever we would miss a match load, instead of it falling into the bot and getting stuck, it would simply just roll off nicely so we wouldn't have to worry about double possession. Motor placement, so on our intake, we just have this nicely tucked in one. It's chained 1-to-1 back, so it's direct 600 pretty much. We have 6 motor drive with just a motor stack. And then on our catapult or puncher, we have just one here. I guess to add to the puncher, we triangle brace across here onto our main brace. It bent a little bit, but it was overall pretty good for what we needed it for. And then Evan from Team C rigged together some LEDs to the bot. These worked really well. We didn't have them changing colors because we didn't have a 3-wire. Similar to C Team on the catapult, we just had extra weighting here for more inertia when going over.
I'm Sean from 29295B, and this is our bot for VEX Over Under 2023-2024. So let's start with the drive. We are running a 360 RPM drive, 55 watts on 2.75 inch wheels. I think the most interesting part of our drive here is the fact we're using 5.5 watts down here geared up so that they can gear on the same ratio as the motors. 360 RPM is a good ratio for us because it gives us enough speed to be controllable yet still competitive. Moving on to the intake. Our intake, as you can see, is very different. And that's because of its requirements to be able to fit under the net, which we saw was a great strength at our local competition. So if you come in here a little bit, you'll be able to see that we have a hard stop that's not very high up. And that's because it allows us to still come under the net while still being able to intake tri-balls. So it lets us still intake tri-balls effectively. It's a trained 600 RPM flex intake, which is strong enough to hold onto a tri-ball, but good enough to not burn out. We're using a high strength axle here to cross brace because we found that when we used a C-channel, that it would have been completely unable to come into the net in this direction, which we just couldn't have. One of its weaknesses is that it's less consistent than a regular intake, but for what it needs to do, it does. Next up is the wings. So our wings are locking, so they come straight out horizontal, and they use a double pendulum mech so that none of the force is applied on the piston, allowing us to keep the safety of our piston in good enough shape, and to allow us to not have give on wing usage. I would say the most impressive part about this bot is going to be our rotational arm. And this thing uses a rotational lift connected to this axle to make sure it comes all the way up and it doesn't keep pushing when it doesn't need to. We felt that this lift was required because we saw great strength in fast match load and the ability to descape. So when we rebuilt for this bot, we really wanted to make sure that was an aspect we incorporated. So what we have here is we are running a 36-12 single slip on the 12 to a 100 RPM torque motor. This is a good enough ratio to let us match load effectively while still having the power to get over. If you come here, you'll see a ratchet that takes the force off the motor, which allows for the motor to not break when you use it for an extended period of time. Our kicker is a flex wheel kicker, which is braced on the back. It kind of sort of works. So we use a flex wheel here because it's a good enough material that allows us to properly impart force onto a tri-ball without damaging it, as you can see here. So we felt this kicker design worked really well because it needed to be compact and usable, and it's more or less both. So let's talk about the arm. This arm, I don't think I've actually seen anybody do it before, but it basically works by having this motor spin this gear, which forces this arm, which is attached to here and here off the same joint, to pull down. This arm has posed more problems than it's worth, unfortunately, but its biggest upside is that it lets us come under the net while still being able to act as a regular shooter. This arm is running on a 12-60 20 RPM lifting mech, which would have been good for a climb if we got one out in time. As mentioned, this rotation sensor here lets us track when the arm is completely down and completely up so that we're not skipping gears unnecessarily. We have an inertial here that we use for our autonomous skills and match autons. Our radio mount is flimsy, to say the least, and it hasn't broken yet, and it went through provs, so it's not in terrible shape, but it meets the requirements to fit under the net, which is by and large the hardest part of this thing. As far as polycarb goes, we have a little bit of polycarb in here to hold these axles together, here on here too. And we had a little bit of polycarb on our wings, which were taken off. Our sleds are unique, not super unique, but they are designed. So what we noticed about our sleds earlier in the season was that they kind of just sucked, and there's no way to sugarcoat that. So we decided to look at some of the other designs and found that having a steeper angle was actually more effective for coming over the barrier.
Thank you so much for watching. Congratulations to everyone who's qualified for Worlds and Provincials. I wish you good luck. And I'd like to shout out X-Toe Alliance, Null and Void Alliance, Golden Alliance, TPA Alliance, Cotton Swallow or Mentor.
I'd like to shout out our mentor, Andrew Bradshaw. I'd like to shout out Indian Food Alliance.
Shout out Project X, shout out Cyberstorm Alliance, shout out 4-Inch Alliance, shout out Siege, shout out Brandon, shout out Capsnuts, shout out Bozeman, shout out Lucas, shout out Tyler, shout out Phoenix Robotics, we love those guys.
Yeah.
Shout out Disco Bots, he's right there.
Just R though.